If you look down from the top of the Eiffel Tower on a clear day, you can see the entire city. Around you, in every cubic meter, there are 10 trillion atoms, which is a lot. If you want this number to get smaller, you have to leave Earth. At an altitude of 100 kilometers above the surface, the number of atoms per cubic meter drops to 1 million trillion. At a third of the way to the Moon, there are 7 million atoms, and in the outer space of the solar system, there are 1,000 atoms in each cubic meter. The closer we get to interstellar space, the fewer atoms there are. Now, what happens if we leave the Milky Way? In intergalactic space, the number of atoms falls to 10 atoms per cubic meter. If you pay attention, space keeps getting emptier and emptier. The space between galaxies is thousands to millions of light years empty, but this emptiness does not mean pure nothingness. Each galaxy is connected to another by an invisible force. This connection can sometimes stretch across billions of light years. With these invisible connections, they form galactic clusters and superclusters. They move toward each other like magnets and form dense structures, like this point, and this point. But what about here? What is happening here? What is going on inside this empty region? This is the emptiest place in the entire known universe. It's called the Boötes Void. And in this video, I'm going to enter this darkness. You will see things in here that you won't believe. But this is a reality that is happening. The universe is made of two main parts: walls and empty space. The walls are the places where a huge amount of matter is found. This matter can be atoms, it can be galaxies, and empty space is where you almost find nothing but emptiness. You might not even find an atom there. What's interesting about empty space is that it can even exist between the walls, like the empty space between Earth and the Moon. But the space we are looking for is something else entirely. The smallest empty space that has been discovered is about 10 megaparsecs in diameter. Each megaparsec is 3.2 million light years, so 10 megaparsecs equals 32 million light years. And large empty regions can be up to 10 times bigger, 320 million light years. Spaces this large aren't just called voids, they're called supervoids. One of the largest supervoids ever discovered is 2 billion light years across. And here's the interesting part. The Milky Way lives inside this space. We're not dealing with that one for now, because the real void is right here, the Boötes Void. Located between the Shapley, Hercules, and Corona Borealis superclusters. This region is strangely empty. Its diameter is 330 million light years. The day telescopes discovered this place, the images were shown to scientists and they couldn't believe it. In this enormous space, only 60 galaxies were found. 60 galaxies in an unimaginable darkness. Yes, we call it empty space, but it was expected that at least 1,000 galaxies should exist in here. And all of this is because of those clusters. Theories say that, in the past, the Boötes Void wasn't actually this empty. It was full of galaxies. Galaxies that were all connected to each other, one by one. But they were pulled away by several invisible forces, stolen from inside this region. The first force is the expansion of the universe, or dark energy. A force that increases in speed the farther it gets from Earth, and even reaches a point where it surpasses the speed of light. The second is dark matter, a substance that glues everything together. For example, it can hold the objects of the Milky Way so tightly that not even a single star gets separated from it. And it can even pull smaller galaxies from outside and draw them into the Milky Way. And the third force is gravitational attraction, like the Great Attractor. These three forces glue small, empty spaces together and also separately pull the galactic walls together, so the result becomes this giant, empty region. The Boötes Void is the least populated place in the entire known universe. To understand how empty it is, imagine looking at those 60 galaxies from a different perspective. It's like considering the distance from the west to the east of the United States as 330 million light years. And as you move from west to east, you can only see a few cities. And those cities represent the galaxies inside the Boötes Void. Scientists have given the Boötes Void the nickname the Great Nothing. And, interestingly, this region was discovered in 1981, before the creation of powerful telescopes like Hubble. The distance between each galaxy is so vast that light from galaxies outside the void takes hundreds of millions of light years to reach a galaxy inside the Boötes Void. If we lived inside one of these galaxies, until 1960, we wouldn't have known that any galaxy other than our own even existed. And this is while we discovered the first galaxy only in 1923. On a larger scale, there is another empty region about 2 billion light-years across. Not as empty as the Boötes Void, but still enormous. So why are we focusing on it? Because we are actually living inside it. When telescopes began observing the surroundings of the Milky Way, they realized that for billions of light-years, galaxies are spread out, with huge distances between them. Sometimes the distance between two galaxies reaches over 10 million light-years, and sometimes even more than 100 million light-years. It's true that we consider ourselves to be a part of the Virgo supercluster, but the void does not mean absolute emptiness. Even a cluster or a supercluster can exist inside a large cosmic void. The largest void in the universe contains several galaxy clusters. And right now, you are living inside it. With the lowest density of galaxies in a region nearly 2 billion light-years across. Me, you, the Earth, the Milky Way, the local group, and even part of the Laniakea supercluster are all inside this giant void. And what's even more strange is that we are very close to the center of it. Our position in the universe is like living in a remote village instead of a big city. The big cities are the dense walls of the cosmos, and the villages are the isolated galaxies scattered far away. Since these cities are denser, their gravitational influence pulls the villages toward them. It's true that the sky of our galaxy isn't very bright, but compared to the Boötes Void, it feels full of light. Just imagine that right now, a civilization like ours is living inside one of those distant galaxies. They would probably consider the entire universe to be just the nearby galaxy clusters around them, like Corona Borealis and Shapley. Their idea of the size of the cosmos might be completely different from ours. The future of the Milky Way is not the same as the future of one of those galaxies. The Milky Way is influenced by the center of a supercluster called Laniakea, and in the future it will be drawn into a terrifying galactic whirlpool. In the future, the sky of the Milky Way will shine with hundreds of thousands of galaxies, but the skies of the galaxies in the Boötes Void will become even darker than they are now. Dark energy, dark matter, and gravity are helping us move toward the crowded, urban regions of the cosmos. But for those 60 galaxies, the opposite is happening. They are being held inside this dark cavity. Even the nearest galaxies are still being pushed farther outward. The large structures and dense walls of the universe are becoming more compact. Cosmic voids are expanding, and any galaxy that fails to enter this migration route will probably remain trapped inside this supervoid forever,